In this problem, we're told about the iPhone, which has become really quite popular, and we're looking at the quantity sold in millions 2 years after 2007. So if you were to get an idea of what this graph might look like, we see that there's a vertical intercept at about 5.3, and so it'll start to look kind of something like this initially. There's actually a little bit of a downward trend in the model, but it continues to go up, and even as recently as now, we have a sort of a quadratic, almost on the border of exponential type growth. So in part A, we want to estimate the rate of change of iPhone sales in 2011 by letting H approach 0. And then it tells us that we're just going to need to select multiple values of H. So remember, all that means is that the H determines what my input value is going to be. So if I'm interested in 2011, that means T is equal to 4. Okay, well, if T is equal to 4, now I want to pick H values around that to kind of give me some other inputs to compare T equals 4 to. So typically we've been choosing H equals plus or minus a half, plus or minus 0.1, and plus or minus 0.01. So what does that mean? That means I'm going to be comparing T equals 4 to 3.5, and I'm going to be comparing it to 4.5. Now what I mean by comparing is we're going to find the rate of change between the fixed point at 4 and then each of these 2 points. Some points before 4 and some points after 4. So then we get plus or minus 0.1 puts us at 3.9 in this direction and 4.1 in this direction, and 0.01 puts us at 3.99 and 4.01. Okay, so just to kind of clarify here, this is when H is negative 0.5, this is when it's negative 0.1, this is when it's negative 0.01. There's really no H here, not associated with it. Here's a positive 0.01, a positive 0.1, and a positive 0.5. Okay, so that basically means that now we're going to find the rate of change between these points. So if you can imagine, here's T equals 4, and what we're going to do is we're really interested in knowing what the rate of change in iPod sales is in 2011, and we're going to compare it to 3.5, find the rate of change. We're going to compare it to 3.9, find the rate of change, 3.99, find the rate of change, and we're going to do the same with these points over here. And hopefully that'll allow us to figure out what's happening right in 2011. Okay, so rather than do this by hand, we're going to go ahead and enter this equation into our y equals screen. And so clear out whatever you have in there, and we'll type in 3.9 x squared minus 6.3x plus 5.3. And now what we're going to do is we're just going to go ahead and use our vars button again as usual to find the rate of change between each pair. So we'll have a total of 6 rates of change to help us figure out what to do. So we'll have 3 here, and then we'll have 3 here. Keep in mind that we have to keep the T equals 4 fixed because that's where we're trying to estimate the rate of change. So we're going to do, okay, what's the output when T equals 4? And we're going to do, oops, I'm not really sure what I hit here. And so we're going to do y1 of 4, parenthesis, minus vars function y1 of 3.5. Now remember, we're only going to need to do this once to have to go to vars and enter all this in, because then we're just going to recall this line and make edits to it as needed. So then we need to divide by the change in the inputs, 4 minus 3.5, and that tells us that that rate of change is 22.95. So we have 22.95. Now we see that the rate of change looks like it's going to be increasing, so we should hope that the slope starts to get a little bit bigger as we go. Okay, well now we want to find the rate of change between T equals 4 and T equals 3.9. So all we have to do is recall that entry and change 3.5 to 3.9. We hit enter, and we do in fact get a rate of change which is a little bit larger. Now what are the units for this? We see that the output represents quantity sold, so we'll write millions sold. And what is that per? Well, our input is years, so it's millions sold per year. Now this is not how many are sold every year, this is by how many more are sold every following year. And so now we're going to come back here and recall the entry to do 3.99. We'll do 3.99, and then over here we'll do 3.99, and we get 24.861. Okay, so there are 3 slopes before, or less than 4, and now we're going to try to guess what's going to happen here right at 2011, and I'm going to guess it's going to be around 25, because notice that there was a big jump in the rate of change and then a really small jump in the rate of change, so it appears that it might be around 25. So I'm going to do the same thing, except now I'm going to go on the other side. I'm going to compare 4 to 4.01, and so I'll do 4.01, and then down here I'll do 4.01, and so that gives me 24.939. Okay, well I was wrong. In fact, the rate of change right there isn't 25. In fact, it doesn't quite reach 25 yet. So we're going to guess it's around 24 pretty close to 24.9. So maybe we would need to adjust our estimate and say it's probably closer to 24.9. So that was a bad guess, and this is why we need to check both sides, because sometimes it's a little bit deceiving. It doesn't always work out to be nice and pretty. And so now we'll do 4.1, and then we'll do our 4.5, but I think we're pretty set. We just want to make sure that that the rate of change continues to increase. There's not something funky going on with our equation. So that gives us 25.29, and now we'll do 4.5 just to get our 6th rate of change, and just to be sure that it continues to go up, which it does, 26.85. And these are all the slopes for average rates of change between 2011 and nearby points. But our estimate for what's happening right at 2011, the snapshot, or the instantaneous speed, is 24.9 million sold per year.